All right, so let's move on to question 3. So question 3 is going to be, let's go ahead and scroll up. Does the line of regression estimate the sample data with at least a 99% confidence level? All right, so question 3 is going to be, does the line of regression estimate the sample data with a 99% confidence level? So what we have is we have the correlation coefficient of our sample. So I'm calling that R samp. And that's what we got in the previous question. So that was 0.996. All right, so we got that. So this is what we have. So I'm going to put that that's given. But what we're going to need is we're going to need the R critical value. Right? And let me explain to you why we need that R critical value. Is we need to draw this number line, which is going to go from -1 to +1 with 0 in the middle. And so this is a number line of correlation coefficients. And what we need is we need some positive R critical value, and we need a negative R critical value, because the positive and negative R critical values separate what we consider to be a good estimator on the outsides, and in between these two critical values is what we consider to be a bad estimator. So we know right now that the correlation coefficient of our sample is 0.996. But where is 0.996 going to fall? Is it going to fall on this side of the critical value or this side of the critical value? Is it going to be a good estimator or a bad one? That's what we have to find out. And in order to figure out where 0.996 is going to fall, what we need is we need to figure out what the R critical value is. So in order to figure that out, we need to use the calculator. So with the Texas Instruments calculator, I've loaded a custom program into the programs here. Oops. On the Texas Instrument. So if I hit program, go down to R critical value. Okay, first it wants the sample size. So what was the sample size? Let's see, we had 1, 2, 3, 4. So we had 4 datums. Okay, so our sample size was 4. And let's see, we have a confidence level of 0.99, which means we're going to have a significance level of 0.01, because together those will add up to 1.0, right? So let's come back to here. We'll have a sample size of 4 and a significance level of 0.01. Enter. It's going to be two-tailed. So we have 0.99. So that's going to be our R critical value. So our R critical value is 0.99. And if we put 0.99 there, we can put 0.99 there. And it actually looks like just barely this is going to sneak past into the good territory, just barely. So we're going to end up with a good estimator of the data. But let me show you how to do this with the NumWorks calculator. And you'll notice that in this problem, I put a link to the calculator that I made in my open math. If you're looking at this as a PDF, when you click on that, it should open up. It should open up this page in your browser. So we have a sample size of 4. Oops. 4 with a significance level of 0.01. We hit submit. It gives us the same critical value of 0.99. Okay. So the answer to question 3 is that, let's see here, let's do answer to question 3. It's going to be that y hat being equal to, what was our equation for the line of regression? Let's erase that down there. So y hat equals 11.53x minus 0.81 is a good estimator of the sample data. That is our answer. All right. So didn't take up much space, on the page. And we didn't have to go into a lot of detail with this illustration that we just drew in here. But it was enough to kind of show what we did and how we came to our answer. All right, let's move on to question 4. So question 4 is, does the sample line of regression model the population line of regression with a 99% confidence level? So let's come down here. So we're going to have question 4. So does our line of regression model the population line of regression significantly different from 0? So we're going to be creating a confidence interval around the slope of the line of regression, and we want to see if 0 is going to be included in that or not. All right, so we're going to be looking here at the Texas Instruments calculator, and we'll look at the NumWorks calculator. So with Texas Instruments, we need to go back to our statistical tests. So stat button, tests menu. And then the second to the last one should be ln-reg t interval. Okay, if you're using an older Texas Instruments 83 calculator, you have to use the custom program that I made. Let me change these values here. Okay, if you're using the older Texas Instruments, you have to go to the Programs button and use this program. All right, and with the NumWorks calculator, we need to go back to the home screen. So let's click the home button. And you want to go to the Inference app. Click OK. We want an interval. Click OK. We want to do an interval around the slope. like that. And this is where you get to choose the data set that you're using. So it's X1 and Y1. Okay. Scroll down. Now we need to change the confidence level to 0.99 and hit next. All right. Yeah, that's our slope. Okay. Margin of error, that's E. That's going to be fine. Scroll down and click next. And here's our confidence interval. So we should end up with like 3.94 and 19.12. So let's see here. So we're going to end up with 3.94 and 19.12. All right, so pardon me while I change this answer down here, because that was based off of incorrect information. Oops. 19.12. There we go. And so what we're going to want to do is put this on a number line. Just a quick sketch, right? Because here's 0, and we want to see if 0 is in that interval. Well, we've basically got +4. So this would be where +3.94 would be. And then +19.12 would be somewhere out here. And so you can see inside this interval, 0 is not in there, right? So our line of regression, this confidence interval is showing that the slope of our line of regression is significantly different from 0 because 0 is not included in that interval. Okay. So what we'll write for an answer here, sorry, my computer is frozen. Here we go. Okay. So what we're going to write is, therefore, maybe, okay. So my computer is a little frozen at the moment. Don't quite know why. Apologize for the delay here. Let's see, while maybe Word is trying to catch up, let me go over here to these calculators. So we'll do linreg t interval. Okay, we want the x list to be list 1, the y list to be list 2, with a confidence level of 0.99 like that. And we'll hit calculate. You can see we get this positive 3.94 and 19.12. Okay, and with the older calculator, run this custom program I made. Okay, our x values are in list 1. Our y values are in list 2. We want a confidence level of 0.99. And it's going to chew on that for a little bit. Give it a second. There we go. And see, we get a positive 3.94 and a positive 19.12. Okay, with all these same values. So let's come back to Word and see if it'll let me continue to write. So therefore, there we go. y hat is significantly different from no correlation, okay, which would be a slope of 0. And so y hat does model the population line of regression. Okay. Let me put in here that this is ln reg t interval. Ln reg t interval 83. All right. So, the amount of space that we needed, to answer like 3 of these 4 questions could fit on one page, and it didn't require more than just using a calculator function and seeing whether zeros in here, drawing this simple number line illustration and seeing where our sample line of regression, our correlation coefficient, lands compared to the correlation coefficient critical value. Up here, kind of putting the correlation coefficient on that table, and then just kind of graphing the scatter plot to see if there's a linear trend or not. Okay. So actually executing all this stuff, there's a lot of different things, but they're not really long and drawn out by themselves, right? All right. So that concludes this think, pair, share. Let me know if you have any questions.